Okay, well, natural resources class, here's fire science video lecture number 2. Stayed up late thinking of that one. Yeah, so we left off last time talking about some things that fire managers pay attention to when it comes to trying to fight a fire with type of soil, weather patterns, smoke they see, rate of spread, dimensionality of the fire, all that stuff. How about some adaptations then that God's put into species that allows them to survive, actually do well in fire, actually sometimes depend on fire. So some of those adaptations would include the following. The thickness of bark some species have. So here's typical white birch. White birch is not a fire-adapted species. White birch bark is wonderful fire starter. I've been told you can get it to light even if it's wet. So it's really good at starting a fire, not good at stopping a fire. White birch would not survive a fire. Bur oak or white oak on the other, well, if I can, sorry, one second. Bur oak, on the other hand, is a type of white oak that we have on campus here. Here you can see the incredibly thick layer of bark around the actual wood portion. So the only living part of this tree would actually, there's some cells, we're going to call them parenchyma cells, topic for another day, that are actually alive out in here, but not very many. This is all dead material. This is all dead material. The only living cells are right at this interface between the bark and the wood, with a few exceptions scattered out in here. And so the tree is trying to keep those alive. It's got this thick layer of bark that is an attempt to do that. And so bark thickness, bur oak, white oak are examples, like I've shown you here, of trees that have an adaptation to survive fire. Jack pine cones. Jack pine is another one. No, jack pine. What's a jack pine? You might ask. Might you ask that? I was talking about jack pines in this last fall when in this same class I offered a section in the fall, and I mentioned that jack pines are not usually seen as an aesthetically pleasing species, and I insulted one of my students because their front yard was full of jack pines, but I'm sticking to my guns. Jack pine, not usually seen as an attractive tree species. There's a jack pine for you. Okay, it's kind of a younger one. Here's an older jack pine stand with some dead ones mixed in. If I can scroll down a little. There, I can't quite get at that one. So yeah, not generally seen as a real attractive species, but they have these cones that are adapted to fire. And you say, well, what do you mean by that, Brian? Well, here, let me show you. So here's a jack pine cone that's been heated up, and typically sunlight is sufficient to heat it up. But also, right on that same limb is another cone that's still closed. So if we look at jack pine trees, here's what those cones look like in the closed or unopened condition, and yet here's a limb displaying both. The adaptation is this: once that cone opens, the seed falls to the ground and is at the mercies of the elements. But this one, they're all tightly packed inside each of these little flaps. There's a seed underneath there, and I will show you. This is another demo I'll do in class on Monday when we get back. And there's a seed that's protected in there. And the thinking is this, that I don't know if trees think, but the adaptation is this, that as fire comes along, it burns the tree, and the heat from the fire will open this cone. I'll show you this in class, but it doesn't just come through and hit the cone and boom, it opens up instantaneously, because then the seed would just fall to the ground and be burned up. But rather, that heat sort of triggers a mechanism in here, and that cone gradually opens up over the next, half hour, 2 hours, 3 hours. It'll gradually open up and release its seed gradually. And in that time, the fire will have passed by, and then there will be just a nice blackened ground that the seed can fall on. And that blackened ground will warm better in the spring of the year and aid the germination of that tree. And so here you have an adaptation where you have probably sufficient heat from the sun to open these cones, but this one's just a little bit different. That wasn't enough to open it, and so it's sort of saving itself for the possibility of a fire coming through. We call that serotinous cones. And jack pine around here, lodgepole pine out west. Still some debate that over whether or not those are actually two separate species or not, but they exhibit that. They are a fire-adapted species. Another adaptation out west is deep-rooted plants. So on the side here, you can see we're down to 10 feet deep right here. Okay, this is your normal bluegrass or yard grass, and it's got a rooting depth of less than 6 inches. If that gets burned, chances are that root is going to take damage that might, kill off some or all of it. But these deeply rooted prairie species are adapted to fire, and the fire may burn off the top, but the plant will stay alive and regerminate from what's beneath the soil. And so in your notes, that's deep-rooted prairie grasses and the brushy species we call mesquite. Another adaptation is something you see commonly in Australia. That's what you're looking at here. These are epicormic buds. See, this whole stand has burned, but it was probably a pretty quick fire came through there. It can't be a real heavy fire, but a rapidly burning brush fire killed the trees, well, or so we thought. But lurking underneath that bark are dormant buds called epicormic buds that once the fire passes, that heat has triggered them to sprout, and it will regrow green material, vegetation, on those burned trees. Here's another look at that same fact, same process. Epicormic buds sprouting on a burned tree. Also, there are lignotubers. There are these widened bases of trees like you see here, and those will burn, but they will deep inside retain dormant buds that then after the fire passes will themselves sprout and reestablish a forest quickly, because that tree has all the underground root system to support that growth. It doesn't have to reestablish all that subterranean growth. All the roots are still there. Okay. Oops, didn't get it. My bad. So here, epicormic buds and lignotubers. Eucalyptus, that's the species of tree we were looking at here. There are a number of different species of them, but eucalyptus displays that very well. We'll talk another time about epicormic buds. There's another form of them that we see in the pin oaks that we have on campus, but that's not a fire adaptation. It's a dormant bud, but for a different reason. Also, you go down to Australia, and you will see sort of this bluish haze that's in the air. These are pyrogens that eucalyptus actually produce, and they release into the air because remember, eucalyptus are fire adapted. So one of the ways they suppress other non-fire adapted species is by encouraging fire, periodic fire. And these pyrogens that create the blue haze that you see here help do that. Trees around here have similar chemicals that are produced. If you remember in the video, they talked about junipers being 5-gallon cans of gas. Well, some of that is that junipers have elements to them that burn very readily and encourage fire. Well, another I don't know if I'd call it adaptation, but at least a consideration when it comes to how to fire behavior is, I've already mentioned it, this blackened ground that you see here. I'll talk a little bit later about what's going on here, but this blackened ground, I already mentioned it, that really warms up quicker and it aids germination. So that's a plus. There are some species that really take good advantage of that. Around here we have species that are adapted to fire, and those would include, I got to get these bumped over here a bit. Pardon me for a second. Those would include, come on now, red and white pine. So that's what we're seeing here. Here's a red pine. Here's a white pine. And notice there are very few limbs down low. They naturally prune themselves, and even with this white pine, Not really any live limbs till up here. That means that it's going to be more difficult for a fire to jump up and three-dimensionally crown out in these types of trees because they shed their lower limbs. And so that's a fire adaptation as well. Now I've been showing you some, or I've been talking about some fire control attempts, and we collectively now call those prescribed burns, and that's what's going on here. They used to call them controlled burns, but very often they don't look very controlled, and so, yeah, we call them prescribed burns. So what's going on here is that the desire is to burn this patch of grass, to simulate the natural fires that came through this area. They've created a fire break here. They've exposed mineral soil, piled up all the organic material over here, exposed mineral soil, and now what they're doing is called backfiring. And by the smoke here, you can see that the wind is blowing that direction. But they're lighting this on fire and backing that fire into the wind. What they're doing is they're expanding the fire break here, creating an area of burned material that's widening here, so that when they go to the other end and light this fire up and the wind drives it, a raging fire to this other side, it hits this area and dies right out. And so there's a gentleman here that's burning up here, another gentleman that's lighting a strip behind him, and they're going to widen this area, create an area of burned fuel that will stop the fire because it has no fuel any longer. So that works really good unless you have a firebrand that gets across and then off to the races you go. So we would call that a prescribed burn. And the idea is to reduce fuel load. It's to simulate natural condition. Lots of deals. The purpose is to control the timing and extent of the fire, though. That's the real job. Now, these fire breaks, they're exposing, as I say, mineral soil and backfiring. That's what you see in your notes. And if we look at some other examples here, that's the one I showed you at the top of a hill. If you do decide to get your red card and work on a fire crew, this is what you'll probably be doing first. Trying to mop up, trying to find any hot spots or sources that might be ignition points the next day. And this person here is actually cutting a fire break. This looks like down south. It looks like Saw Palmetto. And so this person is probably preparing an area for a prescribed burn to dispose of logging slash. Yep, they still do that. I think I had another fire break picture. Maybe not. It's called Fire Breaks 2. We'll see if I can find it here quick. You're paying for this. Okay, Fire Breaks Part D. If it will open up. Maybe it won't open up. Be that way. Oh, there it is. Okay. Gotta move me out of the way here. Yeah, this is the one we already looked at, the tractor. And here's a farmer, very typically with some farm programs now, they're required to burn land entered in, for instance, the CRP program, the Conservation Reserve Program. And again, the purpose is to mimic natural conditions. Here they're creating a fire break, and the goal here is to make the fire break twice as wide as neighboring trees. If this tree catches on fire, burns, falls across the fire break really isn't of much use. So they're trying to make this fire break twice as wide as the neighboring trees, and in hopes of stopping the fire. And here's mineral soil exposure again, trying to get that dark stuff out of the way and expose that underneath soil. Already talked about that one. And here's some people practicing cutting fire line, hand cutting fire line. If you're a smoke jumper, jump into an area, that's likely what you're going to be doing, is hand cutting fire line. It's not glorious, but it's effective. All right. So that's fire breaks. I already mentioned main fire starters. Lightning is the main fire starter by number of acres burned, and arson by the number of fires started. That should make sense. Arson fires, if they're started by people, must occur in areas that people can more easily get to, and so more easily fight those fires. And so we can put them out quicker. More of them are started, but they're successfully fought at an earlier stage. Lightning fires can be anywhere. They can be in hard to get at remote areas, and so that oftentimes results in more acres burning. Other causes: down power lines, smoking, trains. You're going to see in that tractor video of the guy cutting a fire break through his wheat field. I think it was a cigarette smoke, because you'll see it started in the ditch of a road. Not this last December, but a year ago December, it was so dry out west that wind blowing dust around created static electricity that started some fires. And this last December was privileged to get to fight a fire that started in a manure pile. People had piled manure up in preparation of spreading it on a field. It was damp enough and compressed enough, it spontaneously combusted and lit on fire. Not a good day. So technological differences then. We've already alluded to a number of them. You saw smoke jumpers, you saw planes dropping, fire retardant, you saw aerial photos of fires. And so contrast that with this being the technology that was available, for instance, in Peshtigo. They talk about the Black Hawk, the town's fire engine, looked like this. So you get a group of guys on this side cranking that lever up and down. Here was your water, and they would create the pressure to squirt that out there. And you're looking at that conflagration that was burning 100,000 acres an hour, and this is what they were fighting with. That's truly taking a cap gun to the Battle of the Bulge or something. It was of no use. This fire end, the Black Hawk was interesting because the axles on it were actually metal, and they were melted and twisted, but it left the wooden tongue unburned. Again, sort of that curiosity that goes with those major forest fires, what they do and what they how they behave. Okay, I'm going to stop there. We'll pick it up the last few lines on Monday after I get done delivering the promised demos and video. You guys hold me to that. There are 2 demos and 1 video that I got to show you, and we'll take it from there. So you have a good day, have a good weekend, and I'll see you on Monday.